we're going to work on lesson 3-3, which is on page 155 in your math book. Divide whole numbers by fractions. So this is going to be something that is possibly new to you, and this is really cool. All right, so here we go. Reciprocals. This is a new word that we're going to be taking a look at and using during our lesson today. Two numbers whose products are 1 are called multiplicative inverses or reciprocals. The inverse property of multiplication states that the product of a number and its multiplicative inverse is 1. So this is something you will hear during this lesson. The vocabulary, as you can see, are the words that we just highlighted over here in this section. But the inverse property of multiplication, multiplicative inverse, and reciprocal. Those are things that we are going to be taking a look at today. Now, here are some examples of our reciprocal or the multiplicative inverse. So 2/3 times 3/2 or 3 seconds, 3 halves equals 1. And as you can see, all that has happened is the denominator became the numerator and the numerator became the denominator. They kind of flipped there. And we talk about that and how the reciprocal is like flipping the fraction, where numerator becomes denominator, denominator becomes numerator. Here's our examples. Find reciprocals. Find the reciprocal of 1/8. Since 1/8 times 8/1 equals 1, the reciprocal of 1/8 is 8/1, or the number 8. Remember, any number over 1 is also the whole number. Or if you have a whole number that you need to make into a fraction, you can put that whole number over 1 to create your fraction. So the reciprocal of 1/8 is 8. What's the reciprocal of 1/7? The reciprocal, remember, we would take and we would flip it. It would become 7/1 or 7. Example number 2, which is on page 156. Example number 2. Find the reciprocal of fractions. What number multiplied by 3/4 has a product of 1? So 3/4 times some fraction equals 1. So we need to think about it, and we need to use the word reciprocal. So the reciprocal of 3/4, remember, we would take the denominator, make it the numerator, take the numerator, make it the denominator. So the reciprocal of 3/4 is 4/3. And when you multiply those together, you create 1. Because think about this, 3 times 4 is 12. Because with multiplying fractions, you multiply numerator times numerator and denominator times denominator. So 4 times 3, 12. And remember, when we have a number that is the same for the numerator and the denominator, it equals the whole number 1. Here's our check. What number multiplied by 4/7 has a product of 1? So we have 4/7. What do we multiply 4/7 by to equal 1? And remember, we would find the reciprocal, and that would be 7/4. So 7 times 4 is 28. 4 times 7 is 28, and that also equals 1. Example 3, still on page 156. Find the reciprocals of whole numbers. The whole number 5 can be written as a fraction. And it's real simple. I've already mentioned that. All we have to do is take the whole number and put it over 1. Since 5/1 times 1/5 equals 1, the reciprocal is 1/5. So we just take the numerator, make it the denominator, take the denominator, make it the numerator. So the reciprocal of 5 is 1/5. What's the reciprocal of 4? So we know 4 as a fraction would be 4 over 1. The reciprocal would be 1/4. Continuing on, we are on to page 157. Page 157 at the top. This is something that you may be doing in class. Let's go down to learn divide whole numbers by fractions. So we can use these visual models, our bar graphs, or we can call them tape diagrams, bar graphs. So we can say you can use these visual models to represent division problems involving whole numbers and fractions. So if I take a look at these, I can say find 3 divided by 3/4. So I'm going to draw the 3 to represent the dividend, the 3 bars. And then I'm going to divide those. It says divide each whole into fourths. So if I'm taking a look back at our original problem, up here, 3 divided by 3/4, we're dividing the bar into what number we would have as the denominator. So I will take the 3 bars and divide them into 4 sections, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Then here's where we're going to start showing the dividing up. So using 2 different colors, as you can see in your book, we're going to take and look at identifying the groups of 3/4. So here's one group of 3/4, 3 of the 4. Here's another group of 3/4. Here's another group of 3/4 and another group of 3/4. And as you can see, there are 4 groups of 3/4 in 3 holes. So here's one hole, another hole, another hole. And what we're doing is we're saying, okay, here's 3/4, here's another group of 3/4, here's another group of 3/4, and a fourth group of 3/4. So that is one way to visually represent 3 divided by 3/4. And we would know that would be 1, 2, 3, 4 as our answer. Continuing on to the top of page 158. At the top of 158, you can also use equations to solve division problems involving whole numbers and fractions. Recall the multiplication and division are inverse operations. This is something that we talked about in a previous lesson. Inverse operations, that means they're opposites. So you can divide a whole number by a fraction by multiplying the whole number by the reciprocal. I know that seems kind of confusing, but here's the example of it. So we're going to write the equation, 3 divided by 3/4. That's the equation we had on the previous page. Now we're going to take this problem that we had, and we are going to take the whole number and create a fraction. So I'm going to put 3 over 1, because 3 as a whole is also represented as 3 over 1 to make a fraction. So now instead of 3 divided by 3/4, we have 3 over 1 divided by 3/4. So we have 2 fractions. We're going to divide now fraction by fraction. And remember, we can go ahead and we can do the reciprocal. It means we're going to keep this 3 over 1. We're going to change this to multiplication, and then we're going to do the opposite. We're going to do the reciprocal. We're going to flip it. So we're going to, instead of having 3/4, we are going to put 4/3. So this problem here, 3 over 1 divided by 3 over 4, is the same problem here. We're just using the reciprocal to help us because we already know how to multiply fractions, and it's really easy. So we can use the inverse operation in order to help us, the reciprocal. So here we go, 3 over 1 times 4 over 3. We're going to do 3 over 1 times 4 over 3, and we would go ahead and say 3 times 4. We could do it this way, 3 times 4 is 12. 1 times 3 is 3. Another way, and then we would take this and we would say 12, how many 3's are in 12? And that would be 4. Or we can find common factors. Now, common factors would be a factor that we could use in order to help simplify first. So we would take and we would take a look at this and we would say, okay, we can simplify, or another way to talk it is cross cancel, is another way you may have heard a teacher say it, as a cross cancel or butterfly method. So we are taking a look at these two, and these are both 3. And I know that I can take 3 divided by 3 to cancel or simplify and to create 1. 3 divided by 3 is 1. 3 divided by 3 is 1. And guess what? We've already simplified. Instead of doing this step, we've already simplified it. And we can say 1 times 4 equals 4. 1 times 1 equals 1, or the answer of 4. So 3 divided by 3/4 is 4. That's the same answer we had on the previous page when we were looking here with our modeling. 3 divided by 3/4 is 4. That was on page 157. So showing it with the bars, or showing it here with writing the reciprocal and doing the fraction, changing to a multiplication, and then reciprocal, we can find the same answer. Continuing on to page 159. At the top of 159, we're now going to take a look at dividing whole numbers by fractions. We're still doing that. So here's another example of how to do it. So find 2 divided by 2/3. So here's a method using our visual model. We'll go ahead and do our 2 bars to represent the 2. And then we're going to draw. Remember, we're looking at the denominator to see what number we're going to use to draw different sections within our bar. So we have a 3, so we need to do 3 sections in each bar. 1, 2, 3, 1, 2, 3. Then we are going to group them together in 2s because we were having 2/3 in our problem, in our original problem. So here's 2, here's 2, here's 2. So we could say there's 3 groups of 2. So how many whole groups of 2/3 were labeled? And there are how many sections left over? So how many groups were labeled? Here's one group that was labeled. Here's another group that was labeled. Here's another group that was labeled. So we have 3 groups that were labeled. And were there any sections left over that weren't grouped? Nope, we don't have any. So I'm going to make 0, or I can spell it out, 0 sections left over. So with that in mind, we can say 2 divided by 2/3 is equal to 3. So this is one way to show it with our bar. Now, let's look at the other method, which we would have with reciprocals. So I flipped over to page 160. So our second method, here again, we have the same problem that we had on the previous page, 2 divided by 2/3. So I'm going to take the 2 and make it into a fraction. So I'm going to put it over 1. So I'm going to take that whole number, put it in the numerator section, take 1 and put it in the denominator. So now we have 2 over 1 divided by 2 over 3. And now we're going to do the reciprocals. So we're going to take the 2 over 1, leave it the way it is, take the seconds, instead of dividing, let's multiply. It's reciprocal, it's the opposite. And let's take 2/3 and flip it. Let's make it 3 over 2. The reciprocal of 2/3 is 3 over 2. Let's go ahead and do the multiplication. 2 times 3 is 6. We could do it this way. 1 times 2 is 2. And we could say 3 is the answer if you did not simplify. Or here's, I kind of like the shortcut. You can simplify. So I have a 2 and a 2. I'm going to say 2 divided by 2 is 1. 2 divided by 2 is 1. Sorry, 2 divided by 2 is 1. So now I have 1 times 3 and 1 times 1. So I've already simplified it. So if I have 1 times 3, it would be 3. 1 times 1 is 1. And then what I'm going to do is I'm going to say I have 3 as the answer. So I will take a look at this, and it's the same answer that we had when we were using the bars. 2 divided by 2/3 equals 3. Let's do the check on page 160. So our problem is 4 divided by 2/5. So let's go ahead and use method 2. I really like to use method 2 if they're not asking me to show it with visual models. It is really nice to be able to just quickly put the numbers down to help our algebraic mind think about what is happening in this problem. So I have 4 over 1, because that's the first thing they say to do, is to make that whole number a fraction. So I'm going to do 4 over 1 divided by 5. So I took this whole number and put it over 1. 4 over 1 is the same as 4. We didn't change that number. We just represented it in a different way. Now it says we need to do the reciprocal. So I'm going to do 4 over 1. That's going to stay the same. I'm going to multiply, which is the opposite. And I'm going to take this number 2 and this number 5 and put them in their reciprocal spots. So 5 over 2. So if I take a look at this, I could do this. 5 times 4 is 20. I could say 1 times 2 is 2. How many 2's are in 20? And that would be 10 wholes. Or another way, let me just show you doing a simplified. We have 4 over 1 times 5 over 2. That's the same problem that we had here. And I can use common factors. 4 has 2 as a factor. So I could do 2 divided by 2 is 1. 4 divided by 2 is 2. And if I take a look at that, I have 2 times 5, which is 10. 1 times 1 is 1. Remember, anything over 1 is that numerator, 10. So it depends on what you would like to do and which one works best for your brain. If you would like to multiply and then simplify, or cross cancel and simplify and then multiply, you are fine with that. I'm going on to page 161. On page 161, this is example number 5. So here we go with another example. And it says, divide whole numbers by fractions. At summer camp, the duration of each activity is 3/4 of an hour. The camp counselors have set aside 4 hours in the afternoon for activities. Find 4 divided by 3/4 and then interpret the quotient. Remember, quotient is another name for answer. So here we go. We're going to use models. So it said we have the whole number 4, so we created 4 bars. We looked at the fraction, and the denominator was 4. So we took each bar and divided it into 4 sections. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then you have to identify the group, and we want groups of 3/4. So here's one group of 3/4. Here's one group of 3/4. Another group of 3/4. Another group and another group, and one left over. So I'm labeling this 1, 2, 3, 4, 5 groups and one left over. Now this is important. Now what do we do with that leftover one? Well, let me show you. It's really easy. So what we have here, there are 5 whole groups. We already counted them. 1, 2, 3, 4, 5 whole groups. And there's one section left over. One section left over. That one right there. And that section is one of the 3 that we need to have to create another whole section. So in this case, we have one of the 3 left over. Okay, because we have groups of 3, 1, 2, 3. We have one of those. So we can't make a group unless we add 2 more to have a group of 3. So there's one of those 3 left over. I always try to do this, do some little dots here. So I would have, if I had these 2 here, I could group it together to make another whole group, but I only have one of them. So I only have one of the 3. So one section is 1/3 of a group. So I can use these two numbers together, or this 1/3 and 5, in order to create the answer. So 4 divided by 3/4 is 5 and 1/3, because we have 5 sections and one of the 3 left over. So we have 5 and 1/3 as the answer. Now this is what it would look like if we are taking a look at our other method that we were using, not the bar method. So we have 4 divided by 3/4. Here's the equation. And then what we're doing is we're taking that 4, putting it over a 1 to make a fraction. So now we have 4 over 1 divided by 3 over 4. And then we're going to do the reciprocal. 4 over 1 times, and we're going to flip this, 4 over 3. Then I am going to say, can I cross cancel or simplify? 4 and 3 do not have common denominators, so I have to leave those alone. 1 and 4 do not have common denominators. I have to leave those alone. So we can't cross multiply or cross cancel. Cross cancel or butterfly. So we have to go ahead and do straight across multiplication. 4 times 4 is 16. 1 times 3 is 3. So we have an answer of 16 over 3. And then that's an improper fraction. So what we need to do is we need to say, okay, how many 3's are in 16? So 3 times 5 is 15. So we could do 5 wholes and then 1 of the 3 left over. So this is another way that we could show and say the same answer. 4 divided by 3/4 is 5 and 1/3. So the quotient is 5 and 1/3. So a camper can complete 5 and 1/3 activities in an hour. Now, last one on page 162. Check. Morgan has not a 9-foot piece of wood. He wants to cut let me start again. Morgan has a 9-foot long piece of wood that he wants to cut to build some 5-6-foot long shelves for his bedroom. So I'm going ahead and I'm circling the important numbers I need to have. Find 9 divided by 5, 6, and then interpret the quotient. Interpret the quotient is just saying, give me the answer. What does it mean? So here we go. We have 9 divided by 5, 6. And remember our steps. I'm going to use the steps from method 2 that we did up above. So if you want to look up above to refer back to it, you're more than welcome to. So I'm going to create 9 over 1 divided by 5, 6. So there's my problem, my two fractions. I'm going to take this and leave 9 over 1. I'm going to do the reciprocal, so I'm going to multiply and then flip this over, 6 over 5. And let's take a look at this, because if I look at it, let's see if I can cross cancel. Sorry, let me move it up. Let me see if I can cross cancel. Do I have common factors here for 9 and 5? No, I can't. How about 1 and 6? I do not have it. So I have to go ahead and multiply straight across. 9 times 6 is 54. 1 times 5 is 5. So again, if I take a look at this, I have an improper fraction. So what I need to do is create a mixed number. How many 5's are in 54? There are 10 of them, because 10 times 5 is 50. That would leave 4 left over to create the fraction. So I have 10 wholes and 4/5 left over.